Hello students, today we'll solve some questions of a straight line. The first one is draw a quadrilateral in the Cartesian plane whose vertices are minus 4, 5, 0, 7, 5, minus 5 and minus 4, minus 2. So these 4 points are given. First we have to plot these 4 points in the graph. That will give us a quadrilateral, and after that we have to find its area. So first of all, let us plot these 4 points. The first one, minus 4, 5. Its x coordinate is minus 4 and y coordinate is 5. So we plot this point taking x as minus 4 and y as 5. This is 5. Thus we get the first point. Now the second point is 0, 7. You can see that its x coordinate is 0. So you don't have to take anything on x-axis. Just take 7 on y-axis. That will give us this point B. So we've got this point B. Now similarly, for C, you can see that x is 5 and y is minus 5. So by taking x as 5 here and y as minus 5 here, we get this point C. Now similarly, we can get this point D. So we have plotted the 4 points in the graph. Now by joining these 4 points, we get this quadrilateral which you can see ABCD. So we have got this quadrilateral ABCD. Now we want to find the area of this quadrilateral. In order to find the area of this quadrilateral, we draw this diagonal AC. Now from the figure you can see that this diagonal AC is dividing the quadrilateral into 2 parts. First one is the triangle ABC. This one, the upper one. This is the triangle ABC. And second one is this, the lower triangle ADC. So we've got these 2 triangles. Now we will try to find the areas of these triangles. And from the figure you can see that if I add these 2 triangles, I will get the area of quadrilateral. So we can write our first equation as area of quadrilateral ABCD is equal to area of triangle ABC plus area of triangle ACD. Now students, we know that area of a triangle in coordinate geometry is half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. This you have studied in 10th class. Now by using this formula, first I am trying to find the area of triangle ABC. For that I take x1 y1 as point A. This point A is my x1 y1. B is x2 y2 and C is x3 y3. So I will take these 3 points as x1 y1, x2 y2 and x3 y3. So our x1 is minus 4. So this is x1 minus 4. Now y2 minus y3 is 7 minus 5. That is 7 plus 5. x2 you can see is 0. So 0 multiplied by the whole term becomes 0. So there is no need to substitute the values of y3 and y1. Now the third point x coordinate is x3. So we'll substitute the value of x3, that is 5. y1 minus y2 is 5 minus 7. So we have substituted the values of x1 y1, x2 y2 and x3 y3. By substituting the values we get, this is 7 plus 5, 12. 12 into minus 4 is minus 48. Minus 10, that is minus 58. Minus 58 by 2 is minus 29. So we've got minus 29. But you know that area of a triangle or for any shape, area can never be negative. Hence, we leave this negative sign. So the area of triangle becomes 29 square units. So we've got the area of triangle ABC. Now we'll try and find the area of the second triangle, the lower one, that is the triangle ACD. Now in this triangle ACD, I am taking A as x1, y1, I am taking D as x2, y2, and C as x3, y3. Now we'll again substitute the values in the formula. Half x1, x1 is minus 4, y2 minus y3 is minus 2 minus minus 5, that is minus 2 plus 5. So we've got this much. Now x2 is minus 4, this is minus 4, y3 minus y1, that is minus 5 minus 5, then x3 is 5, y1 minus y2 is 5 minus minus 2, that is 5 plus 2. So we have reached up to this point. Now we'll simplify this. 5 minus 2 is 3, 3 into minus 4, minus 12, minus 5 minus 5, minus 10 into minus 4 is 40, 5 plus 2, 7, 7 into 5 is 35. Now simplify this. 40 plus 35, 75 minus 12, that is 63. 63 by 2, that is 31.5. So we have got the area of triangle ACT. As we have written in equation 1, that area of quadrilateral is the sum of areas of these two triangles. So we'll add the areas of these two triangles. The first one was 29, second one 31.5. We'll add these two to get 60.5. So this is the area of quadrilateral ABCD. Next question is, find the distance between P x1 y1 and Q x2 y2 when first case is PQ is parallel to y-axis and the second case is PQ is parallel to x-axis. So first of all, we'll plot the first point P x1 y1 and then the second point Q x2 y2 on the graph. So let this be the point x1 y1 where x coordinate is this x1 and Q is x2 y2, x coordinate is this x2. Now in the first case it is given that PQ is parallel to y-axis. From the figure you can see that this line PQ is parallel to y-axis. Now if PQ is parallel to y-axis, that means the distance of P from y-axis is equal to the distance of Q from y-axis. These two distances are equal, therefore x1 becomes equal to x2. Since PQ is parallel to y-axis, so the distance of P and Q from y-axis are same. That means x1 is equal to x2. Now we know that the distance between 2 points is given by this distance formula. This you have studied in 10th class. Now since in this question x1 is equal to x2, so these x2 and x1, these will be cancelled. These two terms will be cancelled. So what we are left with is y2 minus y1 whole square. This square will be cancelled by the root. So the final value is y2 minus y1. So we've got the answer y2 minus y1. Now second case. In second case, PQ is given parallel to x-axis. So the figure will be like this. PQ is parallel to x-axis. In this case, since the line PQ is parallel to x-axis, so this distance y1 and this distance y2, you can see from the figure, these two distances will be equal. Now again we use the distance formula. In this distance formula, since y1 is equal to y2, so this term y2 minus y1, this will be cancelled. Now from the figure you can see that y1 is equal to y2. Since y1 is equal to y2, therefore, when we use this distance formula, this term y2 minus y1, this will be cancelled. So we are left with root x2 minus x1 square. This square will be cancelled by the root. So the final value which we get is x2 minus x1. So this is the final answer for the second case.